Hello and howdy, ladies and gentlemen. Root Beer here, looking at question 23, the very middle question of Part C on our 2018 Fermat contest. So, what have we got with question 23 here? Suppose that A, B, and C are integers with x minus A times x minus 6 plus 3 equal to x minus B times x plus C. For all real numbers, x. Okay, so this is going to be true for any x I bother to choose. The sum of all possible values of b is, okay, sum of all possible values of b. We are limited to having integers. So things that immediately draw my eye, this plus c, or sorry, not plus c, plus 3. The fact that we've got minus signs over here but plus signs over here seems a little interesting. But also this 6 is oddly out of place. It's not like it tells us a root of this polynomial over here, but it does sort of give me a starting point because this statement's true for all the numbers, right? So we could say something like, let x be 6, and then I don't really care what happens with a. Because then I'm going to just get 3 on the one side, 6 plus b, and 6 plus c. Okay. But b and c are integers. So b plus 6, c plus 6 are also integers, which means they must be factors of 3. So 6 plus b and 6 plus c, they have to be among, well, as pairs, I guess we could say they have to be 3, 1, or 1, 3, or negative 3, negative 1, or negative 1, negative 3. There's only so many possibilities with 3. If they'd made it something like 6 or 7, we'd have a lot more. Now you could just say, well, okay, 6 plus b can be 3, 1, negative 3. And then b can be, subtract 6 from each of these. And you could get negative 3, negative 5, negative 7, negative 9. Or you could say, well, the sum of all 6 plus b's, and there's going to be 4 of them, is going to be 3 plus 1 plus negative 1 plus negative 3, which adds up to 0. And then you've got 4 extra 6's that you've added on, so subtract 24, you'll get negative 24, or you could just add these ones up and get negative 24, because negative 12 and then another negative 12. But either way, my b values add up to negative 24. And is that one of the possibilities? Yep, there it is. It's b. Okay. I think this is probably the fast way to go about doing this question. I wonder whether or not there's another way. The fact that you've got A, B, and C as unknowns would be really kind of annoying to try and expand this out. Now, you might get a little relief from the fact that the possible values B can take on are the same as the possible values that C can take on, so that's nice. But this A here is a real wild card, and I think if you don't see that x equals 6 gets rid of that A, you're going to have a bit of a problem. But, you know, as I often say, feel free to leave a comment below if you had a different way to do it, and you found a way that doesn't just involve plugging in x equals 6 to get rid of A. If you expanded these out, please let me know the details, because I can't think of a way to do it with that. Despite the fact that, you know, if you don't see that 6, that might be your instinct to, oh, these polynomials are equal for any x's, expand and compare coefficients. I think the A will really end up ruining your day there. But, as I say, let me know if it's different. And I will see you guys in the next video for question 24. Until then, please take care and have a wonderful day.